All right, good afternoon, everyone. That's like really loud. Trust me, that was more painful for me than it was for you. No one should have the privilege of hearing their own voice that loudly. So Wednesday afternoon, how's our energy? Is everybody like maintaining? Did the break help? You guys all get some sugar? There's a lot of sugar out there. Um, Hopefully you guys are able to sustain and I'll forego a joke about being between you guys and a cocktail or dinner or something like that. But hopefully I think we'll have a really good conversation here. As we were kind of, the board and Debbie and other members of ESIG, we were thinking about, how do we want to use our spring technical conference? What do we want to talk about? And we had a couple, things validated from our brand. We've had a lot of new people attend the spring conference, and as I think about it, ESIG is a very special place for very bright and highly intellectual people to come together to talk about the foremost issues in energy. However, one of the things I've started to advocate for with the board is, how do you kind of bridge this gap between academia and building the actual, equipment, putting the steel in the ground in the field. I thought that, given all that we've experienced since COVID, the state of play with utilities in terms of our infrastructure development, it's a really good time to talk about supply chain. And that's kind of buttressed, if you will, by some of the work that my company's done at Xcel Energy. So just in case you don't know us, we're a fully regulated and vertically integrated utility. We're in 8 states. So basically the thing about like the Midwest, so we're everywhere from like New Mexico, Texas, through Colorado, then up into the Dakotas, Minnesota, Wisconsin, and Michigan. So what that means is we own a little bit of everything. We have one of the country's only steam and chilled water businesses. We also have hydro, nuclear, a ton of renewables, batteries, coal, gas, etc. It also means that we get some extraordinarily interesting state policy and, quite frankly, divergent state policy. So we realized a couple years ago we need to better co-optimize our systems, and so we've created an integrated planning organization. I have the privilege of leading that organization, and my group gets to answer the really challenging questions. There's a lot to be done on the technical modeling side of things. I think there's a surplus of experts in the room and surplus of content on that topic, and so I actually don't want to talk about that in any way, shape, or form. What I do want to talk to you guys about, and what I hope our panelists can kind of bring to bear is, I think it's fine to have, a couple system planners sit in a room and debate the numbers. Is it 100 megawatts? Is it 500 megawatts? Is it 400 megawatts? At the end of the day, I think we can all agree we just need more. And so that's what I really want to see if this conversation be is how do we get to that more? Who's the what, when, where, and how of supply chain, and at what pace can we actually do this? So I'll introduce our panelists here. I'll start from my left just to keep that simple, but that won't be the speaking order. But Damir Novosel is the president of Quanta Technology. We're talking about kind of like the solution side. Next to him is John Francis, partner at ScottMadden. And then next to him is Kevin Jacobs, director of supply chain consulting for Mackenzie. So we basically assembled, and I did a lot of polling and outreach to folks as we were assembling the panel. Who are the smartest brains on this? Who knows the most information? Who has the most data? So I hope at a minimum we can ply you with data, overwhelm you with facts and figures, and then we can kind of clean up the mess at the end with Q&A. That sounds all right. So kind of more on the setup, and this is my view of like where we've been. We've kind of gotten through the easier parts of building and operating the grid. I think we all know this. The grid's a little bit over 100 years old at this point in time. We've benefited from those initial rollouts. And so when I think about what it takes to do what we need to do, I think about a couple different things. There's the technology piece, there's the people piece, there's the system tools piece, and there's lots of different assemblies, right? There's different ingredients in the recipe. And I think in the past, it was a much simpler recipe. Capacity came in big tranches. The initial, use of powers was very simple, minor industrial applications, novel lighting, things like that. The next 2 big waves of load growth came in 2 forms, and it's actually really interesting. They're 2 of the fastest technologies that have ever been adopted, actually faster than smartphones or refrigeration, and then air conditioning. Were both adopted in a period of time that was less than about 5 years. Even Apple today doesn't have the kind of market penetration that air conditioning or refrigeration got within just a couple of years of being adopted. It was more or less limited by the grid. So we went through a period of really high load growth and like starting in the 40s and 50s. That kind of went on through the 60s and 70s. And you kind of like look at the makeup of the United States. If the last major build out when a lot of major metropolitan areas were developed really was around like the 70s and 80s, think like Denver, Phoenix, actually Austin, Dallas, the list kind of goes on. So, think about this as like a mental model, like the Eastern Coast cities, like San Francisco, Philadelphia, New York, pretty much anything that's over 100 years old already had a grid. The rest of it was really built in those 60s, 70s, moving in a little bit in the 80s. Starting in the late 70s, you start to get these energy crises as, prices contract, you have a run up in demand, you have a constraint in supply, right? So you're going to live through these kinds of energy constraints. And then you kind of like leveled off into this multi-decade period of conservation and focus on energy efficiency. So what does this all mean? I kind of make the argument that myself included, our regulators, our engineers, our supply chains, our vendors, none of us have lived through a high growth environment. So we're all going to have to learn this as we contemplate, where's this grid going? Again, I think we can debate whether it's 400 megawatts or 40, but I think we can all agree it's going to go up. And you can pick, what is that harbinger of demand? Is it EVs or EE data centers? It all is here. So I think our role as a group is to figure out how do we prepare ourselves for that? What do we need to be looking at? How do we think about risk management? And I think we all learned a lot of lessons in terms of COVID, in terms of how fragile our industry really was in terms of our ability to sustain a business. So again, you think about the scale concept. If you're going to multiply where we've gone with load growth by a factor of 100, you can see how easily it breaks and how quickly it falls apart. I won't spend a lot of time on this. This is, Xcel's view of that version of the debate where you put two planners in a room and you argue over 400 megawatts or 40 megawatts. But we've done a lot of system analysis, and generally, what we see is you kind of layer on all the different policy. Demand runs up significantly. I think maybe an easier way to digest this slide is we also did an analysis. We said, okay, if you think about the average energy consumed by any average residential household, including vehicles, electricity, natural gas, or other, heating oil or propane, or whatever they might have. Today, about 25% of that is served through an electric meter. We then kind of took that analysis, we called it like a residential envelope analysis, and we added on all the policy. We added on all the market-driven adoption of electrification technologies, and then the policy to come up with, 4 different planning scenarios, part of like our Grid of the Future analysis. And what we determined from that is you kind of extrapolate that out to 2040, 2050. You could pick a year. It's false precision to think it's 2041 versus 42. You extrapolate that out, and our view is about 80% of that will need to be served through an electric meter on a nominal basis. So that really, to me, points us in the direction of, okay, how do we build this faster? How do we get the supply chains in place to start building all the things that we need to build? This is just, a high level view, more of like a macro perception of like, what does that mean from a terawatt hour basis? Again, won't spend a lot of time on this, but our current system, and I think we're one of the 6 or 7 largest utilities in the country. Our total system load is 91 terawatt hours. You look at where we're going based on a range of different scenarios as performed by every region analysis. And, you can obviously see the numbers speak for themselves from, full carbon reduction of 40 gigawatts all the way up to 50 gigawatts and everywhere in between. So that's the point of that. From a capital perspective, and I think this kind of starts to get us into the supply chain conversation, we obviously, ran this through a cost model just to understand, what is our business as usual capital requirements mean, and then we benchmarked that with other companies based on these 4 scenarios. And what we saw is generally there's a need for somewhere between $200 and $550 billion for a utility of our size. To kind of push that out further, we also did an analysis where we looked at the number of investor-owned utilities as well as municipals and co-ops. And again, there's a lot of assumptions that went into this math, so don't litigate that with me. I can't back it up. It's like on cocktail napkins. But we determined that ultimately to kind of like get through to 2050 to meet the demand challenges and then fully decarbonize, we need somewhere between $5 and $10 trillion of capital deployed. You think about like what that takes to deploy that kind of capital, it's tremendous. It basically means that we're spending, several billion dollars every single hour of every single day of every single year between now and 2050. And if you guys work for, big corporations like I do, you probably have a sense of, what that requires in terms of, accounts payable, accounts, finance. You have to go finance all this stuff. That's getting harder. If you have regulators that are pushing down your return on equity, I've yet to meet a banker that wants to finance $10 trillion at 5.5%, 6%. It just doesn't work, right? They want to see 10% or more. So there's like a looming problem on the financing as well as the CapEx side. So kind of further translating that into, again, this is our view of just one of our jurisdictions, what has to be true to get to some of these demand numbers. We think that we need to build about 100 incremental substations between now and 2050. That means in servicing about 2 every month. We need to build, we need to work with vendors to get 2 million heat pumps adopted in the state of Colorado. That means that someone on the sales side, right, on the supply chain side, the HVAC vendors, et cetera, they need to go figure out how to sell 10 heat pumps every single hour between now and 2050. I don't know about you guys, but that just overwhelms me. The thing about like trying to achieve some of these policy goals, it's absolutely incredible. So I'll kind of zoom out one last time before I hand it to our panel. We're actually going to give you much more meaningful information than I will. And I'm a man of many analogies, so I really like looking for different ways to contextualize, what we need to do. And I kind of think we're sitting on top of our Rosie the Riveter moment as a country, if you will. I personally think that energy and infrastructure should be the bipartisan issue of our generation, and I think it can fit both agendas. And then I think about, it was the last time you think about the United States really had to kind of like tough it up. We've certainly had some challenges geopolitically, but like the last time, we really suffered as a country and it created, a long-standing cultural impact. I kind of went back to World War II. So curiosity got the better of me, and I, again, got a cocktail napkin out, started penciling some things, and I was just curious, what do World War II costs? In real terms, it's actually only $4 trillion. So quick math, what do we got to do? Like 2 1/3 of World War II's of capital has to be deployed. That's incredible. I kind of went down this whole supply chain hole. Like, how many tons of steel do we have to use in World War II? Just the United States, so 65 trillion tons of steel. You kind of just index that up for, this kind of great overhaul that we're talking about. We need 163 million tons of steel. So on and so on. Obviously, our supply chains got incredibly more complex because, we're now reliant on all these other critical minerals. And so with that, I'll pause and welcome our panelists who, like I said, we're going to fill in a lot more detail than I'm able to provide you guys. So first up, I'd like to welcome Kevin.
All right. Kevin Jacobs, Director with Woodmac Supply Chain Consulting. We help utilities, oil and gas across North America, the globe, and our group specifically in their supply chain divisions deal with a lot of these issues, building out projects, getting reliability work done, dealing with the cost pressures. So I'm going to come at it with some data first and then try to come in with some potential solutions, more on the supply chain side and how utilities and vendors can try to work together to solve some of these, because what's been working, 5 years ago is not going to work going forward. So we're going to focus on the T&D equipment. There's a massive other labor component of this. Talk EPC strategies all day if you want to after this. But from a T&D equipment perspective, we're seeing a few key issues. Steve mentioned some of them. Top one being that supply-demand imbalance, relatively inelastic market, all of a sudden faced with massive growth. The impending tariffs, general policy changes on that list as well. Continued commodity price volatility, that's making it hard for you as a vendor to price out what your material costs, makes it hard as a utility to predict what it will cost, makes it hard as a regulator and as a customer to deal with those cost increases. And then still on the list, maybe not as ranked up highly as the others, but technical manufacturing labor, certainly a shortage there. People don't grow on trees. You want to build a factory, get it done in 2 years, you still need people to work there that might not be trained up. And then finally, shipping. We all went through a terrible time in 21 and 22 with that. It's not gone yet. It's still out there. So I'm going to hit you with some data first, and then we're sharing all these afterwards. So you can take pictures, but you'll also get all the slides afterwards. From a lead time perspective, we track these with our customers across the globe. Graph of power transformers, and you can see that 4-quarter rolling average has been up and to the right every single quarter, basically since 2021 and even before then. John was pointing out the light blip on that last quarter. I take that as more maybe a rounding error in our data, maybe a certain type of data coming back versus a long-term trend. I'm going to have to see several quarters more of a downward trend before I believe in anything there. But the takeaway, I mean, you're at 125, 150 weeks after receipt of order. So you're at 2.5, 3 years. And then the volatility is extreme. You get extremely high lead times. We're talking 4 or 5, that spike in Q1 of 2024. I looked at it. Those are not one-off outliers. Those are 7-year bid proposals from multiple vendors across multiple clients. On the flip side, from international vendors, from repeat business where you have great relationships with a vendor, we see very low lead times. So there's something going on there that you can get some volatility depending on what you're looking for, who you're looking for it from. And then across multiple types of equipment, we're seeing that lead time change up and to the right. Although with distribution transformers, pad and pole mount, more easily inventoried items, I think items that folks had to get their heads around very quickly and some of the manufacturing has come in. We've seen those be repaired. I'm not saying they're low yet. Those numbers are down from maybe a high in 2022, but those lead times are coming down to a far more reasonable level. On the price side, everything is still up and to the right. From what we can see, power transformers again, basically have doubled since the pandemic, and they keep expecting to go up to the right since then. Demand will be continuing to grow. We've seen that across other pieces of equipment, 40, 50% price growth in the last 2 years. And what's really interesting is when we look at what's driving from a commodity basis, steel, copper, aluminum, the labor piece, some of those, and we'll look at in a minute, steel has come down 50% in the last 2 years from its highs. Why is the number still going up when that's such a big percentage? They have what everyone wants. And when you can do that, you can raise margin and you can charge more for it. So this price issue is significant. It's not going away anytime soon. Tariffs, everyone's favorite topic, I'm sure. This is an illustrative look. This could all change based on your specific buying or what comes out after lunchtime tomorrow. But just to give a relative sense of where things are, you know, we're high single digits, mid single digit impacts on imported items, finished goods coming across the border. And then even if you have domestic manufacturing, you're still importing your goods in many situations from across the border, your steel, aluminum, et cetera. You're going to have an impact there. So these tariffs, they're having a real cost impact, as well as everything else going on in this world. Last little bit of data here, maybe the bad news part. So we talked about steel. It's come down from its highs in fits and starts, but tariffs, demand for domestic material, that's expected to keep that upward pressure going. Shipping, we talked about, those 2021, 22 container prices were unbelievable. It's dropped since then, but with the droughts in the Panama Canal, Suez Canal still going through the attacks there, getting a lot of shipping routed around the Cape of Good Hope, adds maybe 8 or 10 days of lead time, but it also adds cost. And shipping's up 3-4x from maybe pre-pandemic levels. It's not a small amount when you look at the amount you have to ship there. And then one piece that I think is worth mentioning is storm frequency. I'm sure some of you, depending what region you're in, feel this more than others, but we took a look at all the utility data we have, how much they spend on storm restoration. And it's never been a small amount, but it has ballooned since 2019, 2020 on a normalized basis there. And that's, you know, comes in fits and starts. You can see the bottom chart there, 3 months before versus 3 months after. What is the spike in certain materials after a storm rolls through? But when those storms start coming one after another, it turns into a long-term trend, even if the spikes are maybe a couple months apart. So there's quite a bit of bad news there. One little piece of good news, I guess, the investments are underway. We're tracking investments in transformers here just to keep the theme going at least. We're seeing $1 billion in the US between 2023 and 2030. That's not a small amount across distribution and power transformers. The problem is there that it's not going to be ready tomorrow. Even if you got all that in right away, or all that started right away, you still have some lag in when these are complete. You need production to start rolling out. You need utilities, traditionally risk-averse folks, to trust that this new production will pass all quality standards, et cetera. So there's quite a lot going on. You can see the breakdown there on the right. You also need the people. We talked about that a little bit. They don't grow on trees. You need people to work these plants. You need people to be installing this, doing the construction. These are folks that are just not available. We're seeing on our side folks that are just not responding to bids because they don't even have the people to put in a proposal to your bid available. And oftentimes they don't have the crews in the field able to do the work. So they can choose the bids that are most valuable to them and they can't respond to it all. You also have to consider all this new manufacturing. They also need power and materials to do this, things that are in high demand that everyone else needs. And you need this manufacturing to get that material, but the manufacturing needs that material to begin with, the chicken or the egg type situation. Same with tariffs. If the goal is to onshore steel, aluminum, etc., you need power to build those plants. You need to connect those to the grid. So this crunch is coming at utility energy industry from quite a few different angles. So we talked about the manufacturing being built. That top title here, electric industry, sits at the center of national security, economic growth, decarbonization priorities, really brought into the spotlight after decades of low growth. That might be a big statement to make, but I don't think it's inaccurate. You have utilities in the middle of having to prioritize who gets what equipment, new housing development, reliability replacements, storm restoration, large load. There's only a certain amount of equipment to go around. And when you have utilities in the center of that having to decide who gets what, you're all of a sudden on everyone's front page. You're talking to regulators. There's politicians calling CPOs and CFOs and CEOs trying to get their equipment for their constituents. It's a different world. And they're also having to do that within the bounds of relatively deglobalizing policy, where a lot more is coming onshore. There's an increased visibility and affordability of everything. Customers are pushing back against rate increases. Inventory costs are being scrutinized. I'm sure most of you at a utility or other organizations see headcount freezes. You're being asked to do a lot more with the same or less than you have in the past. So that statement at the top, national security, utilities are an integral part of data center build out, keeping US data on shores. Economic growth, manufacturing brings jobs. Decarbonization, there's a long-term renewable build-out that utilities have to ensure gets on the grid, and then the equipment that goes into that. And frankly, when Steve touched on a little bit, we're not equipped to do that. I say we, I was an engineer at a utility for a long time. We work with them day to day. We're not yet equipped to handle that from a policy, a tools, a people, a culture, and everything perspective. It's been decades of the incentive system saying, don't screw up. You know, you can take a long time, you can gold plate it, but don't mess up. And all of a sudden, within months or quarters, we're asked to hit 4 or 5 plus, double-digit growth in some regions for load growth. So it's something that, you gotta try to start addressing. I look at it from a supply chain issue. So what can supply chains do about that? In a simple, very, very simplified way, your task is to get a certain amount of stuff for a certain price in a certain amount of time. Directly, supply chains can impact the price piece. They can use best practices in today's world, and we'll cover those in a little bit. What worked 5 years ago might not work now. And then indirectly, there's some optimization. You saw the numbers that Steve put out there. You can't just keep doing what we've been doing and expect to hit those. It just doesn't happen that way. We need to find some utility optimization that just hasn't been necessary in the last few decades. So I'm going to touch on a few of these, a lot of words here. You can read them all later. I'll hit some of the high points. But from materials, what can supply chains do for mitigation strategies? From low to high, top to bottom, that's kind of a level of effort, relatively speaking. Long-term contracts, 3 to 5 year agreements, get into some relationship where you're not constantly bidding and worrying about this. You're actually working together. You have escalation terms that help you not have to negotiate price changes every time. They're tied to indices that make sense. You take care of some of the commodity piece from an equitable perspective. Diversifying supply bases, both from a utility perspective, but also vendors. Diversifying your supply base so you can then work with utilities to handle some of these tariff changes and policy shifts. Supply relationship management programs. These have been pretty infrequent, except for quite mature utilities in our perspective, but they're highly valuable for critical pieces of equipment. Having that transparent awareness of your future demands, the vendors' capacity, their production lines, you have that finding solutions together, getting around pain points together, having that relationship management in place and making that part of the culture is a big shift for many folks, but it is part of getting towards something better. And then we get into the more difficult pieces, forecast and demand planning, alternate materials, technology, standardization, things that as an engineer, I would say absolutely not, but we have to start thinking along those lines of what could be done differently and what is the impact, thinking at it from a commercial minded perspective and making sure all technical T's and C's are in there as well, or T's are crossed and I's are dotted, but finding the balance to make this happen. So that's from a maybe direct perspective. We talked about what worked before, might not work going forward. Just chose a few procurement strategies that we see. Many, frequent RFPs, we use that a lot today. Utilities use that a lot today, maybe vendors do as well. Just, hey, I need something, let's go for an RFP, let's go get it. That's not working. We see that already not working in a supply constrained environment. It's not effective. Those long-term agreements from a services perspective, contractors of choice, spacing these out, taking a very thoughtful strategic approach, and then letting that relationship build for multiple years. It reduces that burden. It can allow that relationship development. It takes a bit more work, it takes some managing, but you start to, when you think about doing something differently, you start to get all that time back on your end and the vendor's end to actually start working on these problems. It works today, it will continue to work in a constrained environment. And then finally, these bilateral partnerships. This is something like, if you're building out renewables and you have a certain number of modules that you need for solar, helping a new vendor invest in a new production facility in return for production slot preference. Something as simple, no, not simple, something like that would be more of a bilateral type relationship. Very rarely used today, but as we have this push towards domestic manufacturing and folks need to know that there's going to be a return on their investment if they're going to build that plant, these can be valuable practices going forward. And then I also want to look, these operational efficiencies, doing more with less. If we take care of the price side, we can still look inward. And the nice thing about these, although they're difficult to do, you can do these and find cost savings in times of inflation or policy uncertainty. Value engineering, I'll pick one or two out in the interest of time. Just value engineering, we see this all the time. You open up, instead of, hey, we want this over there, go build it for us. Take more of an open book approach. Work through that, build time into the procurement process where you can work with the engineers to say, what piece of this is artificially increasing the price? The way we lay the cables, the type of road grade we need, et cetera. Let's work together to mutually be able to drive this cost down in an equitable way, not just telling you to take out $10 million more out of the CPC scope, but actually find the right way to do this and lower the cost of it, and then work those findings back into the next round of work. The spec standardization, we're talking about it up here a little bit, and maybe some of you have gone through it. If you have X number of SKUs of distribution transformers from all across your system, is there a world where three distribution transformers might all actually be served by one SKU, and maybe you pay a little bit more, maybe it's overkill for one of those situations, but you've reduced your SKUs by X%. Little incremental changes like that you can't just do a supply chain. It takes engineering, it takes legal, it takes everyone else to get on board with these types of changes, but they can have an impact over the long term. And then finally, we'll wrap up here. Talked about the first piece. Affordability is certainly on my mind, I'm sure on everyone's mind here. That supply chain management is only going to increase in complexity as we try to navigate all the tensions, everything that's going to keep coming at us for certainly 4 years, probably longer. And then I will say there's an opportunity in a stressed market where there's new tools, AI, there's a lot of newness out there, and there's a demand. There seems like there could be an opportunity for innovation in the space if utilities can embrace it. And I think we all have to start having that mentality of taking, instead of a risk-averse approach, maybe a risk-informed approach to how we approach it, how we go about doing procurements. And then finally, utilities upskilling procurement practices, engaging transparently with vendors, looking internally. There are ways to start making changes that allow us to get to some of the numbers that Steve was talking about. So there's a little bit there. I'm going to pass it off next to another word, Damir.
Thank you, Kevin. Very informative. So I'll introduce our next speaker, Damir Novosel, Dr. Damir Novosel, President of Quanta Technology. And I'll just make a quick point on the bespoke ordering We did an analysis at Xcel Energy where we found that about 85% of all the stuff that we were buying was like specific to Xcel for some reason. And it could be as simple as like, oh, we just want it painted blue, and everyone else wants it green. And so it led to a lot of supply chain challenges. So with that, Mr. Doctor Novosel.
So since we're talking about doctor now, you can ask me, why do I have a tie? No, does anybody have a tie here in this room?
Why do you have a tie?
Oh, there is one person with a tie, so is the reason because I'm old fashioned? Is the reason because I want to be unique? Maybe that's the reason, I don't know. But the reason is, if you look at the tie, I actually want to promote integrated system planning. Because it has T&D, you see the transmission powers here, you see wind, you see solar, you see hydro. I think it's a little bit older tie should have data centers here as well. I think that's the next step for IEEE to have a tie. Well, again, nobody wears a tie anyway. So anyway, I think I'll be providing a little bit different perspective here. I'm approaching this, Steve and I talked about it from the system perspective and how system ties to supply chain. Because at the end of the day, let's say, what's the value of the grid in the energy ecosystem? If we don't understand the value of the grid in the right way, we will not be able to understand where we need to invest, how much we need to invest, and then the speed of investment, how fast we need to do it. And not that long ago, just think about it, how all this discussion about renewables, distributed energy resources, storage, and how the transmission may not be as important. Of course, things have changed in the last few years for better. It's clear understanding now, we move in 765 and so on. So things have changed from that perspective. But it's still, I believe, certain lack of understanding of what the value of the grid is. And I'll use the example of hosting capacity and non-viral alternatives. And we still use the word non-viral alternatives, but I think it's becoming, fortunately, obsolete. Because hosting capacity means that you need to upgrade the grid to be able to accommodate renewables. Okay, utilities are doing lots of interconnection studies, hosting capacity, and all this stuff. And then you have the non-viral alternatives. You say, okay, now I don't have to upgrade the grid because of renewables. And if you're not a technical person, you say, what is this? It makes no sense. But of course, if you understand integrated planning, you would say grid, renewables, data centers, they need electrification. They all need to be planned in an optimized way. And I think that's the key message here. Now we go to data centers with let's co-location. There was an excellent panel this morning on co-location of data centers. And Elliot from Constellation actually gave a really good speech. And what I really like in that speech, he had one slide that showed all the studies that would need to be done to actually do the co-location of nuclear plants with a data center. But my point would be, you cannot really discuss what the value grid provides unless you do these studies. Because you say, I'm isolated from the grid, I don't really need to pay to grid anything because I'm going to be connected directly, the exchange of power will be directly, but you guys as engineers and so on understand grid is synchronized and every element of the grid affects every other element. So tripping a large load or having a fault in the system will have impact on everything in the system. There is essential reliability services that need to be provided. There is a dynamic studies, again, Elliot explained it well from that perspective. But my point is very simple. If you don't think grid has the value, go ahead. Don't connect to the grid at all. Just be completely isolated and that's it. And the other aspect of co-location to me is, what's really the most cost-effective solution? And why was grid connected in the first place? There's a reason for it. I'm sorry. There was no, when there was a generation and the load directly connected, there was not that efficient. So I think we need to step back, especially in the context of supply chain and what needs to be done and how much we want to invest, to understand what's the most cost-effective solution. I'm all for co-location. That's very important to have load generation close to each other. But we still need to have a backup. my background is protection. So I'm a protection engineer. You have to have a backup. It's double systems, triple systems, and so on. So that's kind of the message that I would like to communicate here. So any thoughts on that? Do you guys think, am I on the right track? Okay, good, thank you. Thanks, good. So next slide is on integrated planning. And I'm really impressed with ISIC. I mean, the topics that are here are just really exactly what the tech industry is dealing with. And I learned so much just in this couple of days. So there was also discussion on coordinated planning and flexibility. So we always have different buzzwords, and so flexibility became an important issue, and it is. Because we had generational uncertainties, now we have tremendous load uncertainty. And this is all about the risk management at the end of the day. And the question is now, does integrated or coordinated planning, by the way, I was told just a few years ago that I couldn't say integrated planning, believe it or not. You know why? Because there will be contradiction between state and government, FERC versus state. So actually, I changed my word to coordinated planning, but now I'm seeing more logic, common sense prevails. So now we have integrated planning again, and I like it. But the whole point is, integrated planning is, I would say, is critical to aid in addressing supply chain. Because we really need to optimize how we invest and where we want to invest, what technologies we want to use. I heard here really today from Steve, with Maria and Scott from Salt River Projects, with AP, from Mary and so on, how utilities are now really putting lots of effort. And this whole point of, let's say, low-hanging fruit or no-regret measures are coming out of the type of integrated planning approach. And there's so many gaps yet. I mean, tools are not there, processes are not there. People need to learn and so on. But I think we are really on the right track. But one point I want to make here is there's lots of discussion about affordability these days. You can see now, I've seen some of the utilities actually laying off people because the easiest way to cut costs is, let's say, do these type of actions. But are we doing affordability for now, or are we doing affordability for 5 years? Sometimes making some of the investments now, cut costs now can cost us much more in the future. And the other point of this slide would be that the technologies, I'll talk more about technologies, they can actually address some of the supply chain topics and so on. Next one would be, let's now focus more on data centers. Again, that's of course, the hot topic and so on. Firstly, we talked about risks management, we talked about uncertainties. It's a huge uncertainty. You see on the left side, you see some of the projections and what the growth will be and so on. And utilities have been accused now. I've seen a couple of articles say utilities are now overestimating data center growth so they can make more money. Okay. If you guys remember the Dominion case in Northern Virginia, actually my company did at that time load forecasting. And they said, this is no way the data center growth will be that much. And PJM at the time actually changed the process based on some of this analysis. And still, the data center growth was much bigger than it was estimated at that time. Are we now in the same situation? But again, we will not know. And I want to emphasize the water cooling will be coming with the chips, the GPUs. And that will reduce the usage of electricity. There will be actions, but still, we need to do scenario and probabilistic planning to look ahead on what we see the potential no regrets measures are, and then make sure that we actually move forward, and then let's see how things develop. But I believe by working together and co-optimization, Steve and I discussed that, can really be the best solutions to address some of these uncertainties. And what co-optimization mean? For example, Quanta Services is working with data centers and helping build data centers. also working with utilities to build utilities. How about doing some more optimized work and also looking more from the, I would call it PEPC perspective. So planning, engineering, procurement, and construction. So I think there are lots of opportunities to actually plan and organize it in a better way. Coming back to supply chain, Quanta Services actually acquired 2 transformer companies. What do you think? Why would Quanta Services do it? Quanta Services is the, again, my company is doing front-end part, but there is EPC and so on. Purely supply chain. They said, we don't want to be taking a risk by not having transformers. And the companies were acquired, so Quanta now has that advantage of providing faster response. To your point, we talk about the speed of deployment. And I can tell you, there is a, I think I can say that, there was the request by some data centers, can you guys provide us transformers? And we say, we're not going to sell you transformers directly. If you want to do joint work, we'll be glad to do it and use the transformers, okay? So those are some of the models I think that we need to be evaluating. Okay, let me move forward. The next slide is about technology addressing the reliability needs. Firstly, we talked about this collocation and all the aspects. And just look at on the left side, we had recently 2 events when 1.5 gigawatts of data centers were tripped because of the fault on the system. And there was a major issue because the voltage, of course, went up significantly. And actually, they were able to, Dominion was able to switch off, shunt capacitors and so on, and to save the system. But just think about it now, how, if you don't really plan it well and organize it well, that's how the issues will be happening. So, but coming back again to this point, that what will be the key success factors in addressing some of those needs? By the way, look at the load model on the bottom here. One important aspect with AI is that model is much more dynamic. As model is dynamic, it's much more important to address those dynamic changes, to model them, to make sure that we address the load behavior, to make sure that we are not overly conservative. And if you don't do this, that can really be problems in the system. But it requires, again, a co-optimization, requires data centers, utilities to work very closely together to address that. And I do want to, and I'm not expert on nuclear, just to let you know. But what I've been hearing, and I trust people that talk about it, that nuclear cannot change output very fast. So now imagine if you have data center that is AI, that it has dynamic load, and you have nuclear that cannot do it. So is the cost-effective way now to have diesel generation as or storage can compensate this, or you should still rely on the grid and make it more cost-effective? But again, I'm not now proponent on every specific solution, but I'm a proponent of, because of all the supply chain issues and investment optimization, that we very carefully evaluate what's best for the society and the industry overall related to this, related to this type of investments. Okay, because again, there is this whole, I would say, unfortunately, negative energy. I mean, this is a great thing. We as industry, we want more energy. If Walmart has more need for their products, they'll pick another Walmart. When Disney World was now building in Anaheim additional, they said, oh, we are going to build now parks, we're going to build roads. So what's wrong with our industry saying, let's invest now in the grid, let's invest in making things happen? But we all constantly have to, there's tug of war, who is making this and that, and that's where we heard today that regulatory environment needs to, of course, address that in a better way, okay? I'll skip that slide. It actually talks about electrification And I just want, it's more a technical slide that addresses that we need to have a more granular approach when you're addressing impacts on the grid and where we want to invest. And again, I'm always tying investment with supply chain. Again, there was a great panel on grid enhancing technologies. And I just want to summarize here. What I think it's not right is we now start grouping all these grid enhancing technologies somehow one solution. It's really important to understand which solution serves which purpose. Let's pick up on dynamic line ratings. Dynamic, and we have FERC 881. Dynamic line rating has been for many, many years. And now it's a more push to do it. It's a great technology. I think it's technology that has really opportunity to address some of the congestion issues. And even we heard the presentation can delay some of the investments. So if you have supply chain issues, you may be actually to use some of this technology to help you to weather the storm and so on. But my personal opinion is it's not really good for planning. It's really for the operations. Because in planning, especially if weather temperatures go up and so on, your actually dynamic rating can go down. And how can you plan? Planners need to look into the worst possible cases. You don't want to have blackouts. You don't have outages and so on. So it's very difficult to use technology like dynamic line ratings for planning. As great as the technology is, you need to really find the best application of the technology. That's kind of my message here. And then, of course, advanced conductors. We had a great presentation today, so I don't have to spend more time. I have only 3.5 minutes left. So the next slide, it relates in a way to some of the aspects of how we efficiently design, build, let's say, substations and the overall system. We have lots of now data and lots of information that we can, for example, extend the life of the equipment. Okay, so if we have some supply chain issues, we can extend life of the equipment, but we need to understand what type of, what's the real status of the equipment. So having, sensors and monitors and doing predictive maintenance and all the other aspects that I don't have time to go with. But importance now of digital substation and distributed sensors to address how we can be much more efficient and more effective in designing and operating our grid. I'm going to, this is the slide that I use to very issue very close to my heart, and I'm so glad that Scott Anderson supports me on this from SRP. I really dislike the word synthetic inertia. I think it's something that is absolutely wrong and gives us a wrong perspective of what we need to do. What are we really trying to do? If we have imbalance between load and generation, we need to address how we can manage that imbalance between load and generation. And if we can use inverter-based resources faster, because they are faster than conventional generation, we are solving the problem. But of course, it requires to have reserve margins on the storage or on the renewable generation, and also needs to have controls. And that's sometimes not easy. But again, we're coming back to, what are some of the priorities with supply chain and so on. I think we need to also put some focus on managing the data, managing the how we automate the system better, how we control system better. I think this is a very important aspect of the overall investment in the grid. Here again, just some of the examples when things happen faster. What are some of the technologies that can help address that? Okay, and this is my last slide: solutions for the energy future. So understanding that electricity is the key for achieving all our goals. I think we all understand that. But then again, how are we addressing this? How are we investing in properly doing this? What are some essential factors? Technology advancement. And I do want to emphasize, we talk about supply chain, but there is also supply of people, qualified people and resources they can do the job. I think training, mentoring, getting people into our field is so necessary. And I think there are lots of good examples in the industry that's been done. But I also always want to emphasize that you can have all sorts of different good things happening and addressing supply chain. But if you don't have people that can actually deploy and implement, that's not going to be good. Then standards. This is another aspect of, for me, related to the supply chain. You know, if you standardize equipment better, transformers and so on, if you don't have, just every utility has a specific use of certain equipment, it will be easier to exchange the equipment, to support each other and to manage supply chain in a more structured way. So standardizing equipment, I think it's very important aspect for supply chain. Again, I talked about coordinated planning, and lastly, I have some of the list of the things that are kind of important. I'm not claiming that I have a crystal ball. I'm just emphasizing things that I believe could be solving problems of the future. Coordinated planning, of course, the digital transformation, automating and adaptive monitoring, protection and control. We talk about long-term storage, synthetic gas, small modular reactor. I like synthetic word here, not with synthetic inertia, but with synthetic gas. Small modular reactors, there's lots of hype about small modular reactors. I personally don't believe it's a short-term solution. It will take some time for the technology to be ready, and hydrogen and so on. Thank you.
All right, thank you, Damir. Next up, we have John Francis from ScottMadden. John?
All right. Hello, everyone. First, I want to say thank you to ESIG. Our friend ScottMadden has worked with ESIG for a number of years. Kristen Lyons has been on the board for a while. This is my first time here, but many of my colleagues come, and it's a nice thing to feel like you're coming to speak on a panel and you feel welcomed and part of the family. So appreciate ESIG for the relationship with our firm. ScottMadden's been around since 1983. And sometimes I have consultants and I ask them what year were they, who was president when they were born. And it's often in the 80s and they don't know it was Ronald Reagan or someone else, which tells you how old some of us are. My colleagues that were just speaking, they took an approach, for example, talking about the entire system and then some trends and some things that we're seeing in supply chain. The approach that I'm going to take right now is as if I was a vice president of a supply chain organization at an electric and gas utility. What would I do when confronted with this enormous challenge that we have in front of us? And so a lot of the things that I'm going to present are first to present that challenge, but also what would you do if you were running an organization? And so Stephen gave us a goal, and I loved it, so I wrote it down. I cut and pasted it from his email, so he wrote this for me. But he said, the predominant question is, what must be true to achieve an infrastructure mobilization of this magnitude? And I think that goes on the back of his Rosie the Riveter comment. It's sort of, at this moment in time for these upcoming years, this is gigantic and we shouldn't treat it any differently. And so if I'm a vice president of supply chain and I'm confronted with that, how do I tackle it? He also asked us to engage with you to see what you thought it would take to build the grid that we're all imagining. And so supply chain issues are part of getting that built. And so here we'll open up for some questions and we're interested in what you guys will have to say. And so the title of this is Supply Chain Speed and Scale. I inserted the word utility speed and scale because I wanted to draw a contrast. So first, speed. The projected market conditions caused by the energy transition and the infrastructure mobilization are changing faster than utility supply chains are changing. And that creates a gap. Now, utility supply chains aren't standing flat-footed. They're not doing anything, but there's so much changing around them that it creates an additional challenge. So that's speed. If you take scale, the size and complexity of the energy transition and the infrastructure mobilization far exceeds the investment in supply chain within utilities. So think about how much needs to be done, and then think about the functioning utilities and what they're being given to meet that challenge. They're often asked to do more with less or do more with the same. So those two things create a challenge if I were a leader of utility supply chain. So how can utility supply chains keep pace with the speed and scale of this infrastructure mobilization is a question that we'll tackle. Every year, this is a little bit of a commercial for our firm. We, twice a year, we put out the ScottMadden Energy Industry Update. It comes out twice a year. Our research team puts it out. We're very proud of it. It's on our website. You guys should go check it out. It's a detailed, deep dive into the energy industry. I decided to look at 2022's EIU that we published and compare it to 2024 as a way to describe the speed of change just over the course of 2 years. So back in 2022, there were ambitious decarbonization targets. Natural gas prices were up, which meant that there was an appetite for coal. I don't know if you guys remember that back when Ukraine and Russia were at each other's throats. There were a lot of policy mandates. I mentioned geopolitical events. And that report in 2022 examined these pressures that were being placed on utilities. So there were topics like fossil fuel switching because the price of gas was high. Capital markets and capital needs were growing. Decarbonization portfolios were being implemented or talked about. And then, of course, the interconnection queue, which is always a conversation, were big topics in 2022. Just 2 years later, our EIU is called The Distance, and some of the topics that are in there are long duration storage, next generation geothermal, tackling some of the recent FERC orders around regional transmission planning. When you compare the list of topics just 2 years after our EIU in 2022, to me, it speaks to the speed of change that's present in utilities that the supply chain group has to stay on top of and has to constantly manage. The next page is about scale. That was speed, this is scale. This is a little bit of a repeat of some of the information that Steve and Kevin provided. Sort of, hey, guess what? There's lots of capital flying around. So if you just look at this, this is, if you look in the top right, it says that supply chain operating expense generally grows in single digits between 0 and 3%. So if I'm a vice president of supply chain, my CEO is saying, here's your 0% to grow your organization, but we need you to do all the stuff that's on our list. Sometimes you get 3%. Sometimes you're asked to do with less than more. But when you look at the chart here, this chart is about clean energy investments by quarter from 2018 to 2024. You can see that in the segments, manufacturing, energy and industry and retail, they're all growing by more than that 0 to 3%. It's a way to indicate there's a lot more to do than you're being granted in terms of your OpEx. This is a similar slide. This is just pure capital for IOUs. And this is the 10-year growth from 2014 to 2023. If you compare 96 billion to 171 billion, that growth is 78, almost 79%. And supply chains did not grow that much during that time period. And so once again, you compare this, what are you being given as the VP of supply chain in order to meet these challenges? You have to figure out a way. Sometimes, necessity is the mother of invention, how to get the job done. And we'll talk about that here in a second. And so now I took out the word, or I inserted the word supply chain. It used to say utility. Now we're going to talk about what are utility supply chains doing to meet this challenge, even though they're not being given the equivalent investment dollars for OpEx. We've seen about 4 major things that they're doing. So first is demand planning. In supply chain, there are typically 6 functions. There's demand planning that's way upstream. Then there's strategic sourcing and category management. Then you've got operations procurement, or what people used to call purchasing. Then you've got logistics. And then you've got materials management, which is warehouse and inventory. And we count AP in the P2P process. So those are the 6 functions. I listed them because demand planning is way upstream. And a lot of times people think of demand planning and they say, oh, budgets or the long range plan. But a lot of that information needs to make its way into supply chain so they can do their work. Well, that function in the end-to-end process tends to be the weakest. It tends to have the fewest tools, and it tends to be the most collaborative with the business, the most collaborative with suppliers. And so a focus on demand planning, if you're VP of supply chain, is how can I remove uncertainty for the work that we have to do? I need to get clear with my partners, either in the business or the suppliers, on what's coming. And so I can meet the demands that are coming down the pipe for the next 3 to 5 years if I can get clear on demand planning. Inventory optimization, you know, utilities earn on their inventory if it's on a balance sheet up to their rate case approval, but they often go over that. And so there's a lot of times an effort to optimize inventory, but inventory in the utility doesn't operate the same way as it does in other industries. And so there's been a real effort to stay within your rate case approved level of inventory. The problem is tools that help you do that aren't as capable. And so we've seen some tools emerge, and we've developed a few of our own that I'll describe to you that have some unique statistical models. Then there's looking at your operating model. If I'm vice president of supply chain and I'm only being given this much to do my work, what is a new way for me to think about doing my work? And so there's some movement there. And then Kevin touched on strategic alliances is the other thing. You know, who are the big 10, 12, 15 suppliers that we need to work with in a collaborative way in order to get the major things done, get some innovation. So these are the 4 things that we see in the toolkit of a VP of supply chain or CPO, if they're going to sort of have a fixed level of investment compared to the massive challenge before them. We'll go through each of these one at a time. So demand planning. I mentioned earlier, or a second ago, there are limited tools and technology. So there's a desire for information, but there's nothing that you can buy off the shelf. Your ERP has limitations, Oracle, SAPs, particularly for the utility industry. And so what we've seen is supply chains are starting to develop bespoke tools. And I'm going to describe one here for you in a second. And those tools are used during project planning, way upstream. So if a project is 2, 3, 4 years out, they're using these tools now as a way to capture specs that are being talked about so that they can take those specs and start talking with suppliers instead of waiting until it's closer to milestones in the project. Once they do step 1, they've got specs in hand. And so they can either rationalize the specs, another thing that Kevin said in his strategic sourcing options. They can rationalize or they can gross up in transformer KV or something like that. Once they've got that rationalization done, they can work further in advance with alliance partners. So instead of calling an alliance partner and saying, in 12 months, I need this. Now you're talking to them and saying, in 3 years, I'm going to need this. And for a lot of the OEMs, they can work with you to slot into their quarterly production schedules further in advance. There's more availability if you get to them sooner. And so that's a very helpful thing. And so these bespoke tools, once they're all the information is in, they give you visualization. Now you can see the slots of your suppliers, which slots you have put yourself in, even if it's 3 years out, 4 years out, and how many slots they have left in their production schedule. And all of that is because you got the specs earlier. Right here on the bottom of this is one of the ways that the specs are entered. So I'm thinking about one of our clients. It's a transmission company. They are tripling their balance sheet over the next 5 years. And all the project planners and engineers are out there working on getting the projects done. And they have these minutes that they take to scope. And all the specs of what they want to build are in the minutes, but they never make it to supply chain. And so this tool was developed so that the minutes could put the specs in a tool that supply chain could then use to take to suppliers and begin putting these specs into their production schedule. So the top left is a data visualization of by supplier, GE or whomever, how many slots they have and how many pieces of equipment are each slot by quarter out several years. And most of that is because this supply chain organization was able to get specs earlier in the process when project planning was happening. And so demand planning is one tool that a VP of supply chain in his group has. Second one I mentioned was inventory optimization, so statistical modeling that matches the behavior in utility materials management. We all know that we have critical items, items that sit around, items that are expensive, items that are just for reliability. And it's not an Amazon warehouse out there. And so a lot of times tools and technology will use the wrong statistical model for a different industry on utility materials management. So one of the things that we've started to do is taking the entire catalog for utility, one item at a time, and looked at each item's usage and taken that usage and given it its own distribution. After we give it its own distribution, we review that distribution against 20 plus different types of distribution. You have geometric, negative binomial, Poisson, and each item gets its own distribution as opposed to picking one distribution for your entire catalog. And that's somewhat unique, but I think it also works for utility supply chains. Once you do that, you take your catalog up and you group them and you say, these are critical, these are consumable, these are, and you give them 3 or 4 categories, and each category has a service level. And the way we've translated service level is for each distribution, you have a confidence level. Your critical items get 99% confidence, so you capture the whole distribution. Your consumables is 65%. And so service level equals confidence level based on the distribution that you choose. And once you do that, you develop data visualization and say, okay, based on lead times and usage and the distribution pick and the confidence level pick, which of my items are at risk? And so that is a way to kind of manage inventory in a way that's statistical. There's been the tradition and custom that we've seen in utilities that they'll let the SMEs kind of eyeball it and say, we need this many of these just in case. And this is a way to support that decision-making with some statistics. And so up there in the top left, you can see an example of this item, one item's usage. That statistical model matched that item exactly. And this is just an example of all the different types of distributions that we match one item to one distribution, as opposed to one distribution to all items. Third is operating model. So vice president of supply chain, you've got the number of people, the tools and technology and process that you have, and that's all you're going to get. Can you do work differently to meet the challenges that we've described here, the mobilization for infrastructure? And a lot of what we're seeing are development or deployment of COEs, centers of expertise, and also build out of category management. Category management's been around, it's not new, but there's maturity, and there are ways to support it to get more analysis done by analytics teams that have inputs into category management, for example. And so we've seen more of this to provide value. In this operating model, because you have sort of a fixed operation, one of the things that you can do is expand self-service so that people can help themselves. The more self-service you have, the more people can do other things. There's also virtual agents and bots and FAQs so that more time can be spent on strategic work in supply chain. Expansion of COEs that are aligned with the infrastructure mobilization. And what I mean by aligned with the infrastructure mobilization, if you take something like risk management, we've always done some level of risk management in supply chain, then COVID hit, and then everyone was talking risk. And since then, it's been a big topic. Risk went beyond the financial review of a supplier and it went to things like, if I'm buying from more than one supplier, let's say 3 suppliers, are all 3 of them using the same raw materials overseas from the same company? There are those types of looks at risk that people weren't doing before COVID, that now with the future of this mobilization, there are multiple ways to look at risk so that you can guard against long lead time deterioration. So you can really diversify your supplier pool based on more information about the risk they each provide. So the expansion of COEs, I mentioned risk as one of the key areas that you see. We talked about category managers, but in this case, we're seeing more of them inserted into the capital planning process. Some utilities have capital committees, And they will bring the category manager to the capital committee while things are being planned for the year and for the next 5 years. And then finally, the demand planning that I just talked about become inputs into the category plans. And so these are examples of COEs. I listed risk management, and right there is a leading practice delivery model. So this is a new way of doing work. A few utilities that we've worked with, in fact, our firms we've worked with Mackenzie on a couple of these, have looked at a tiered model where people can do self-help. There's already a centralized set of transactional folks, but work can flow to the COEs, to the more strategic people easily with some enabled technology to help them get their work. Finally, strengthening collaborative relationships. I think this one's already been touched on by Kevin in his presentation. And so establishing internal teams to prioritize potential alliance relationships. I think we usually know who they are, but analyzing their performance, the markets they're in, the suppliers they compete with, and the spend that you have with them. Do some workshops with them so that you can align on objectives, align on outcomes, align on the drivers of value for their firms and yours, and list the high impact opportunities that you see. And once you get that done with them, you assign roles for them within their organization, roles within your organization, and develop action plans with measurable success outcomes. And then you kind of rinse and repeat that as a part of your relationship. This graphic here, and I'll finish with this, is a way of saying that the goal is to work with supply chain, with your alliance partner, and with the business. And in the center there is where we all come together, and that's where the innovation is. So with that, I'm going to pass it back, and we'll open up for questions.